All right, so future elementary educators, we're going to take a look at constructions in this unit going forward, this module that we'll spend some time in. And to do so, we're going to start with copying a segment. So what does that mean? Well, that means that you have some segment like this, and maybe it has a name. We'll give it a nice two-letter name, segment XY, and we're going to want to create a segment that is exactly the same size as XY some other place. So we'll make some other line that's much bigger, and we're going to want to copy this exact segment length in this spot over here. So how in the world do we do that? Well, we use our handy dandy compass. This is a compass. Compasses are great because you can make you can make circles with a compass. Like, that's exciting. You can make a circle with a compass. But the thing that we're going to use a compass for in this scenario is we're going to use it as a measuring tool. We're going to use the compass as a measuring tool. We're going to use the compass as a measuring tool. We're going to extend the compass so that the point is on one segment, one end point of the segment, and the pencil point is on the other end point of the segment, and we're going to make a little arc like this. And what is that? In fact, maybe we'll make it red. What does that do? Well, that signals that I've made an arc. I've measured how big this segment is. Starting at this endpoint, I have made a measurement. This segment is exactly as long as the distance between the compass point and the pencil point. And then we bring the compass to the longer line where we're going to make the copy. And we are going to make a similar arc. Well, because we didn't change the width of the compass anywhere, the distance we measured up here has to be the same as the distance we measured down here. And so if this is point A and this is point B right here, then we know that segment AB is congruent to segment XY. Or the length AB is equal to the length XY. So why does that matter? Well, that matters because let's pretend, shall we, that we have some triangle. Looks like this. And this triangle is triangle CAT, and we want to create another triangle sort of over here that is exactly congruent to this triangle CAT. So I'm going to make a line just as a starting place, right? And so we're going to make AT pop up over here, and then we're going to figure out where C is up there. And we're going to do that using our compass. And because I have planned this badly, we're going to do that down here so that, there, I'm never going to win a YouTube award like this. We're going to bring it down here so that you can see the compass as we're doing the constructions. So the first thing we're going to do is we're going to measure segment AT. We're going to measure it. Segment AT is that long. It's that long. Maybe it's that long. And we're going to make a little arc, and that's going to indicate that we've made a measurement from A to T. We have made a measurement. AT is that long. And then we're going to come over here. We're going to put the compass point over here at the end point of our segment. And we're going to make a similar arc over here. And because we haven't moved the width of the compass point, we haven't changed the width of the compass at all, whatever the length of AT is exactly copied over here. So then you might wonder, how far is it from A to C? Well, from A to C is this far. and we make a little arc, and that just tells the person grading our paper that we've made a measurement from A to C. We come over to here, and we make a measurement. Well, where's the segment? We don't know yet. It's like this, but we don't know exactly. We just know that the image of point C is going to be somewhere along this blue arc. Where? Well, let's measure how far it is from T to C. How far is it from T to C? Well, oh mercy. That's it. How far is it from T to C? It's this far from T to C. Compass point on T, pencil point on C, and we measure. The length of TC is this long. Well, if we bring that over here and we make an arc, what does that tell us? Well, the image of C has to be on this arc, and the image of C has to be on this arc. The image of C has to be on this arc, the image of C has to be on this arc. So this is the third vertex of our triangle. Here's a vertex, here's a vertex, here's a vertex. And so we draw a segment from here to here and from here to there, and this is DOG, where triangle CAT is congruent to triangle DOG. What is the process that we used? Well, the process that we used is called side-side-side congruence. And it's called side-side-side because we copied a side, we copied a side, we copied a side. The three lengths of the sides of this triangle are the same as the three lengths of the sides of this triangle. So this is one of the ways that geometers use copying a segment to ensure that two figures are exactly congruent. And I hope that that is helpful. Next up, angles, they matter too.